All right. Other questions? All right, so let's go through more details of PA1. So you know the behavior that we're after, right? We're making a class-named fraction. You can construct a fraction two ways, numerator, denominator, or just a numerator if it's actually an integer. Four main methods that we used for combining fractions. And these do not modify the fraction itself. If I say x dot add, x itself does not change, okay? It takes the fraction that is x, it adds the fraction that is n, and it creates a new fraction, and that's what the add method returns. So if I just say x dot add, nothing really happens. It does an addition, but I haven't saved it anywhere. If I say y equals x dot add, then y changes, x doesn't change, n doesn't change. So that's the nature of all four of these. So
did you say the fraction doesn't change when we call add, subtract, multiply, divide?
correct.
Okay.
Okay, it takes the number and it adds the argument to it, but it returns a new fraction, which is that new fraction, right? But the argument and the fraction itself don't change.
Okay.
So what do we need to make this fraction class happen? Basically, we need to know what the numerator and denominator of the fraction are. We've got to keep track of that. And those should be class variables as opposed to locals inside a method. So I can just say integer num and denominator. And I'm going to put a comment here which says the fraction is num over denom. So your constructor, when you say I want to construct a fraction with values 2, 3, all you really got to do is copy that first number to num, copy the second number to denom. And that makes your fraction, right? Your fraction is just the composite of these two values. So your constructor just sets these two values to whatever the arguments of the constructor are. So right, just set num equal to top, set denom equal to bottom, and you're good to go. That's your whole constructor. So let's look at toString. So remember, toString is a method that's supposed to return a string that somehow looks like the object. Usually. So if your object is a rectangle, we had toString return the string that says a rectangle, comma, height by width. So we could say rectangle r, right, r dot toString, and it would give us a string, and then we could print it or something. toString never prints anything. Okay, it just returns a string, but usually the person who calls it is going to say print line object dot toString. But by itself, it usually is not going to print anything. So, so how do we turn our fraction into a string? Well, first order, right, just take your numerator, concatenate a slash, concatenate the denominator. Thanks. Right, so just take the numerator, tack on a slash, tack on the denominator. And that'll give you something that looks like your fraction. It's not going to be what you want for the final version that you turn in. Because, for example, if my numerator was 3 and my denominator was 1, this would return the string 3/1. But if you simply make a one-line toString function that returns this, then you can use that to see what your fraction looks like, right? It may not be perfect, but if I get this, I know my numerator is 3, my denominator is 1. That's great. Okay, so for debugging purposes, I would make a constructor that takes 2 arguments, builds a fraction. Okay, make a toString method that just does unadorned numerator slash denominator, or whatever you like. You can say numerator equals this, denominator equals that. Something to let you see a fraction's contents pretty easily. And then go ahead and write the multiply method. Because if you can multiply, then you can add and divide and subtract and all of that. So let's look at multiply. So multiply returns a fraction. It's public. And it takes a fraction, which I'll just call x.
So you said toString returns a fraction?
toString returns a string,
Okay.
which looks like your fraction. So usually a number and a slash and another number.
So all you need to do is make a string?
Mm-hmm.
Okay.
And for the final submission, you've got to do things like if the denominator is 1, don't print out /1, just print the number, and so on and so forth. But for debugging, for a first pass, just print out number /number. Okay, multiply takes a fraction, multiplies this object's fraction by x, makes a new fraction, returns that. And if you can do this, you're an object-oriented programmer. Okay, it's a mental hurdle to be comfortable with this. So let's see what this looks like. Suppose we have a fraction a over b, and we multiply by a fraction c over d. We should get ac over bd, right? So first thing we need to do is we need to figure out what the numerator of our current fraction is. And that's just going to be num, right? That's part of the class. Num is the numerator of ourself. So num is equivalent to a. Now we need the numerator of x. So that could be x dot num. But you're going to make these numerators and denominators private. So to get the numerator of a fraction, we're going to use this getNum method. Again, for first pass, don't worry about private. Just go ahead and say x dot num. But eventually, once num is private, we could say getNum or x dot getNum. But for now, just numerator times x num. That gives us the numerator of our new fraction. So let's just say integer top equals numerator times x dot numerator. And integer bottom equals denominator times x dot denominator. And this is where the slightly weird part is, right? This is pretty clear. This is the denominator of the fraction called x. But what is this the denominator of? When we're using this, we're going to say something like, c equals, fraction 1 dot multiplied by fraction 2. And we start running this multiply method. When we say num, we're looking at f1's num. Right, because we're kind of inside this object that we call f1. When we say denom, we're looking at f1's denominator. So this would be f1's numerator times f2's numerator. Right, so this is the top and the bottom of the resultant fraction that we get from doing this multiplication. So we need to return a fraction, so we want to create a fraction whose numerator is this and whose denominator is that. So how do we create a fraction? We use our constructor. So I'll make a fraction result equal to new fraction, top comma bottom. And I'll just return result.
So basically, s dot num s dot denom is basically it's the second fraction.
Yes, x is the thing we're multiplying by,
Yeah.
and that's the numerator and denominator of that. So in this, it's like C and D.
Yes, yes.
Yeah, exactly. Does that look reasonable? Okay, that will work, and there's a lot going on in there. And the more comfortable you are with this, the more comfortable everything else is going to feel. Now you can do this in one line if you want. You can return new fraction parentheses num times x dot num comma denom times x dot denom. And that'll work fine. But it can be nice to sort of break it out into pieces, and then you can put in prints or whatever. But that's basically how we're going to write all of these functions. Okay, so at this point, you have a constructor, you have a toString, you have a multiply. That's enough to do serious debugging on these three pieces. So write a main method. Okay, make a class, PA1 or something, put a public static void main in there, and have it do things like, so this is main, do things like fraction a comma b comma c, a equals new fraction 2 comma 3, b equals new fraction, 4 comma 5, c equals a dot multiply by b. So comments, a is 2/3, b is 4/5, c should be equal to 8/15. And then system.out.println, c equals, and concatenate c. That will automatically call c's toString method, or you can call toString explicitly if you want. And this should print out c equals and 8/15. But first of all, set a equal to that, and then try system.out.println a equals a, and make sure it shows you 2/3. So that if this isn't correct, if it's a problem with your toString method or a problem with your multiply method. So test your toString first. Once this works, now you can write subtract, divide, and add. And those are fairly straightforward. Division's a little harder than multiplication. So a over b divided by c over d. So just multiply by the reciprocal and write your code accordingly. Addition, you got to find a common denominator. So multiply by d over d, and multiply the second thing by b over b. And then write your code accordingly. Take all of that stuff, multiply it, that's the top. Take all that stuff, multiply it, that's the bottom. Make your new fraction from the top and the bottom and return it. And subtract is exactly the same, but just do your subtraction. So now you got a whole collection of methods for manipulating fractions, for doing algebra on them, which is cool, and you can test those. And make sure your subtract works the right way. X sub n should return x minus n. Make sure it's not doing n minus x. It's easy to get them backwards, so just double check that. All right, and then the last thing is 2-double. And 2-double really just wants to take your fraction and return a variable of type double. And so how do we turn something with a numerator and a denominator into a double? Take your numerator and convert it to a double. So this is how we cast variables in C or in Java. Just write the variable type in parentheses, followed by the variable. This converts num to a double. And then divide that by double denom. and just return that. So if my fraction looks like 2/3, right, if my numerator is 2, my denominator is 3, if I say fraction dot 2 double, that'll return 0.66666667. Good so far? So let's talk about simplification into lowest form, so reduction. We always want our numbers to be in simplest form. So if your fraction is 500 over 100, it should actually be stored with a numerator of 5, denominator of 1. Don't keep things in unreduced form, because here's what can happen. I might make a fraction that's equal to 2 over 1, and I might multiply by a fraction that's 1 over 2, and then multiply by 2 over 1, and then multiply by 1 over 2, and I might do this 10,000 times in a little for loop in a test program, hypothetically. I'm having trouble with that today. So if I were to do this, the result is either 2 or it's 1, right? It's not growing big, it's not going to blow up. This is the number 2, that gets me to the number 1, that gets me back to 2, that gets me to the number 1. I should be able to do this without your code blowing up. But if you don't reduce every time that you do a multiplication, this is going to, after very few iterations, is going to be some gargantuan numerator with the same gargantuan number in the denominator, but when you try to multiply that by 2, it's going to overflow, and you're going to get weird stuff. So the way to handle that is every time that you do anything to a fraction, make sure it's always in lowest form. Okay, and we'll talk about how to do that at the end, but basically find the greatest common divisor, divide top and bottom by it. So when do new fractions potentially need to be reduced? Anytime we do an addition, subtraction, multiplication, division, or when we do a construction. But if you think about it before you leap, and you look at your multiply code, we construct a new top, we construct a new bottom. Well, we could find the greatest common factor at this point and divide these. But guess what? We're going to call the constructor with top and bottom. If our constructor always reduces to simplest form, we don't need to do anything up here. And in fact, anytime we do add, sub, mul, or div, the last thing we do is we call the constructor to create a new fraction. So if you make your constructor so that it reduces to simplest form, you never have to do anything else. That's the only place you need to do this reduction. And doing something in one piece of code is a lot easier than doing it in 5 pieces of code. It's less likely to introduce bugs and so on and so forth. And it's easier to change down the road. So the way I would think of this is inside your constructor, after you've got the numerator and the denominator, find the greatest common factor, divide it out, and that will give you simplest form. And then if you add 2 numbers together, you'll create a new fraction, and the reduced code in the constructor will take care of simplifying it. So some other hints that will keep things easier. Think about displaying your numbers. So calling toString, and then we're going to print out the result of toString. And let me show you some cases to consider. So here's the numerator. Here's the denominator. And here's the result of toString. Okay, if your numerator is 5 and your denominator is 7, you should print out the string, or return the string 5/7. If your numerator is 5 and the denominator is 1, you should return the string 5, not 5/1. Because we never really write fractions with a 1 on the bottom. Negative 5 and 7 should return a string negative 5/7. If the numerator is 5 and the denominator is negative 7, that's also negative 5/7. Return negative 5/7. Don't return 5/-7 because we don't do that. Right? When we write a negative fraction, the negative sign goes in front of it. So you got to somehow recognize this and put the minus in the beginning, and then just do a 7 down here. And that's going to be easy to do in a moment. If you have a negative 5 and a negative 7, don't print negative 5/-7, because this is actually just 5/7. If you have a 0 in the numerator, that's just 0. So if you do 5/1 is just 5, 0/1 will come out as 0. But also if you have 0 on the numerator and 2 on the denominator, that should also just come out as 0. And if you happen to have a 0 and a negative 2, that should come out as 0, not negative 0. So these are just edge cases. They're just kind of annoying pieces you have to take care of. And it turns out you can take care of all of these if you follow one simple rule, which is make sure your denominator is always bigger than or equal to 0. And you can always do that. In this case, it's already satisfied. This case is already satisfied. This is fine. In this case, my denominator is negative. Multiply the top and bottom by -1. It'll turn this into this. And then I can just print numerator/denominator. In this case, denominator is negative, multiply top and bottom by -1. It's going to turn it into this case. And I'll still print 5/7.
So I think denominator always different 0.
Denominator should be different from 0, but there's one more case we're going to talk about still, which is where the denominator is 0. So that's coming up next. So if the numerator is 0, just print 0, right? Ignore the denominator. So, and I keep saying print, what I actually mean is construct a string that looks like this. Don't print it, even though I have a bad habit of saying print. But return a string that's just a 0. All right. I don't know what's counting down. Oh, it's taking a picture. Okay. So I think that's enough to keep you out of trouble with the two-string method. So there's one more edge case, which is division by 0. So for us, if the numerator of a fraction is 0, the number is undefined. 0 over 0, 1 over 0, negative 1 over 0, we're going to treat them all the same as just undefined. And anytime a fraction is undefined, if you use it to add, subtract, multiply, or divide with another fraction, the result should also be undefined. That's just what we're setting up. So in your fraction class, you have a numerator and a denominator. You got a few choices. So one option is to make a Boolean undefined. And you're going to set that flag if you have a denominator of 0. Another option is simply to check your denominator to see if it's 0, and if it is, my fraction's undefined. But somehow you've got to know that your fraction is considered invalid, undefined, and then you have to change what you do in almost every case. So if your fraction's undefined and you're asked to do a multiplication, don't do all that stuff we just said. Just make a new fraction that's undefined, 1 over 0, and return that. If you're subtracting, if you're dividing, if you're adding, same thing. If either of the arguments is undefined, just return 1 over 0. In your two-string method, if your denominator is 0, you should return the string NaN, not a number. Doesn't matter what the numerator is. If the denominator is 0, return that string. and that's spelled out in here. So toString, an undefined number, should return NaN. Does that make sense? So when I wrote this and when I've given this assignment before, I've always suggested just making sure that you check the denominator to see if it's 0. And sometimes that seems confusing to people. It seems like they have more success if they actually set a flag somewhere. So if you want to set a flag that whenever the denominator is 0, you turn that flag on and then you just consult that flag, that's perfectly fine. Okay, just make sure that you don't do anything as far as operating with the numerator and denominator if it's not a number. So this two-double method, where we take the numerator and denominator, convert them to doubles, divide, and return that, we don't do that if your number is undefined. If your number is undefined, instead of returning this, return the following: uppercase double dot NaN. And that's actually a double precision number that you can store in a double variable, but it's a special value which represents not a number. But double.NaN will work just as well as 3.1415 or any other number that you would type. So if two-double is used on an undefined number, return double.NaN. So double is the name of a class. Double with an uppercase D is the name of a class. And I've said everything in Java is a class, and that's mostly true, but not exactly. So integers are a class. There's a class called integer with an uppercase I. And technically, if we want to create a variable named x that's an integer, and we want its value to be equal to 7, here's what we could do. Integer x equals new integer 7. So we're saying x is an object of type integer. We're constructing a new integer with a constructor that takes a value of 7 and that sets x equal to 7. This is a pain. Nobody wants to type this. So there are shortcuts for the most popular types of objects: integers, floats, doubles, characters, booleans, bytes, and so on. So instead of this, we can just say good old int x equals 7. And when we do this, this int is lowercase, right? It's like a primitive. So classes start with uppercase letters. This is not technically a class. It's just a sort of shortcut. So normally when we deal with doubles, we'll just say double with a lowercase d, and it looks exactly like C. But underneath all of that, there's a class called double, there's a class called integer, there's a class called boolean with uppercase letters. And so here's the double class, right? It's from Java language double, it's part of Java language number, which is part of Java language object. And if you look at the fields available in this class, there's a field called NaN. And it's equal to this bit pattern. So it's a double, so it's 64 bits. So there's 16 hex characters here. And it's that particular bit pattern. And if you're really curious, go back to your 270 notes if you've taken 270 and look up the specification of IEEE 754, which is the floating point format. And remember, it has this big long format where we have a sign bit, and we have an exponent, and we have a mantissa. And our number is -1 to the sign times 1 plus mantissa raised to the exponent minus some offset. And if you think about the specification of this, there are some bit patterns that don't fall into the requirements of a double precision number. And this is one of them. So this bit pattern is a special value which is used to represent not a number, NaN. This bit pattern down here is a bit pattern used to represent infinity. And this is used to represent negative infinity. And so if you want to store the value of infinity in a double, you can say uppercase double dot positive infinity. And you can say uppercase double dot negative infinity or dot nan, and it'll load those special bit patterns in. So it's a legitimate double value, but it's kind of different from the other ones. So that's the value we want to return if you call your two double method and it's not a number. Just return double dot nan. Does that make sense? All right, so this is sample test code. This is part of the code I'll use to grade PA1, but this is not what you want to start with. Because if you think your code is working perfectly, if you've done all your testing as you've been developing, you've got all your functions, you think it works perfectly, then you can go ahead and use this main program along with your fraction class and see what it does. And the way I've written this, for example, on this line it should print 5/2 colon, and then it should be followed by 5/2. That's what your to string of this constructor should return. This should just return a 1. This should return a 9/2, -7/2, and so on. This should return 0.33333. These should all return nan. But don't make this your first test, okay, for a few reasons. One, you want to be testing your code before you write add and all these other things, to double and reduce and so on and so forth. And two, if you run this and a fraction's not coming out right and you've never done any testing on your code, you don't know where the bug might be. Is it in toString? Is it in multiply? Is it in the constructor? Is it in the reduction? So be modular, right? Build up in little pieces so that you know your toString is working perfectly, so you can use it to see what a fraction looks like. Whereas if you say toString and it shows you 2/3, is it a problem with toString? Is it a problem with the fraction itself? Who knows? So don't start off with this, right? But you can test this at the end. All right, let me mention the grading on this. So 85 points, I need to change that from 90 to 85 here. That's a typo. 85 points for how it behaves, the functional performance of your class. So if it's perfect, you get the full 85 points. Okay? If most of the functions work, but there's a few glitches here and there, something that I do trips it up, right? Then you get 70 points out of 85. If some of the functions work, but there's a lot of them that don't, it's not just one or two edge cases, then you're 50 points. If most of it doesn't work, but you've got some pieces in there, you've got a constructor, you've got one method working, you'll get 30. If there's no code or if nothing is submitted, it's 0. Okay, so some various buckets to choose from. 10 points for documentation. So, got to have a header block, okay, with your name, the class, programming assignment 1, the date, and a synopsis of what your class does. Okay, your own words, not taken from the assignment. This is a class that implements fractions, something like that. Each method needs to have documentation in the beginning of it. So here's my toString method. What does this do? This returns a string with numerator/denominator. If the denominator is 1, it just prints the numerator, something like that. And then comments on your code as you go through writing each method. Tell me what the non-obvious lines do. Why are you doing each line of code? Okay, so I want to see lots of documentation here. If you have almost no comment, but you do have the header block, you can get 3 points. If you don't have a header block, it's 0 points. And then I'm doing 5 points for how you submit it. Okay, and this is different from the past classes. In the past, if there was a problem with your tar file, if your submission wouldn't compile, things like that, I'd usually try to see if I could fix the problem. And if it was an easy fix, I would go ahead and fix it, and I just grade it as if it had worked the first time. Okay, that's very unusual for computer science classes, and it's probably not going to happen at another school. If it doesn't work, you're going to get a 0. If the tar file is corrupt, you're going to get a 0. So we're going to move away from that. So if everything works and if everything is turned in the way it's supposed to be, you get your 5 points. So that's an incentive to double check the specification. So submission specification. So I want a single tar file called pa1.tar. And it should contain the fraction.java file and any other files that go along with that. If you make other classes, you can include those files as well. Do not include a main method. Okay, so don't include your main class, just the pieces that correspond to this. And don't include the .class files, just the .java. So most cases, your pa1.tar is going to have a single file, which is fraction.java. All right, if you know about package statements, don't use a package statement in here. Okay, put all your Java files in one directory. And I want you to create the tar file from the directory containing the Java files. So I do not want you to do this. I don't want you to sit in the directory above the directory with your files and create the tar from there. So when I untar your file, I should see all the files in whatever directory I'm sitting in. Right? And this is the way that I've always told you to create tar files. And if you do it like that, this will come out correct. But if you specify subdirectories under here and you have source 1 and source 2 and all this stuff, right, that'll be deviating from this. Okay, and do not include your .class files. So that's your 5 points for submission details. Does that make sense?
And you want us to include a make file in our submission?
No.
Okay.
There is no make file here. You could have make files, but I don't want one. Because I'm going to use my own main code, my own main method. So, but on that note, right, when you're developing Java code, you can definitely use make files. Because you got to say Java C to compile and so on and so forth. You can specify, I changed this one .java file, what do I need to recompile? And you can put that in a make file. Java's fairly good about figuring that out, but if you want to practice with make files, that's cool. All right, so let's talk about simplest form. So my suggestion was always keep your fraction in simplest form.
I cannot copy the test function to please.
Say again?
I cannot copy the test function.
From the PDF?
Yeah.
Oh,
Yeah, I cannot copy.
really?
Yeah. When I pay this, it's really weird.
Yeah, I have
Yeah.
problems with that too.
Oh. Well, let me see what it does here.
I think there's a
And I
specific
had,
command for copying text in Linux.
I don't know if it's just like something terminal does. Like,
So I lose my indentation, but it goes in there. So I'm just dragging and then right click and copy.
And then you just right click in Linux and it copies, I believe.
Tell you what. All right, so there's a /temp pa1 test.java that is ugly, but it should work. All right, reducing fractions. So you have a fraction and the numerator is 100 and the denominator is 20. We would like to store this as 5/1. So the way you reduce a fraction, find the greatest common factor, greatest common divisor of 120, and then divide the top and the bottom by that GCD. So in this case, the greatest common divisor is 20. That brings you down to 5. That brings you down to 1. If you have 75/20, the greatest common factor is 5. This is going to be the same thing as 15/4. And then that's in simplest form. So the whole trick is to find the GCD.
250.
Is that predefined in the Java math class?
Yeah, but you got to write it yourself. So find the GCD of two numbers, top and bottom. And yeah, this is 215, right? So take top. We can use percent for modulus. That's the remainder when you divide the top by the bottom. And now you just need to find the GCD of bottom and remainder. And keep doing that until the remainder is 0. And then the last bottom you had is the greatest common factor. You can do it recursively, but you can also do it with just a loop. And recursion is great, but if you don't know how many times you're going to recurse, there's a danger that it can blow things up. And if you can do it as easily with a loop as with recursion, it's usually better, safer to do it with a loop. And this is just a straight iteration. Find the remainder, set the top equal to the bottom, set the bottom equal to the remainder, go back up and just do it in a while loop while remainder is not 0. There's an edge case if the first time that you do this, it turns out the remainder is 0. It's a potential edge case. And this does not work well with negatives. So if you're trying to find the GCD of two integers, first thing to do is probably make these both positive. Find the GCD of that, and then go back and divide your original numerator by the GCD, your original denominator by the GCD. So if I wanted to deal with the fraction -75/20, I would find the GCD of 75 and 20, and say that's equal to 5, and then I'd have -75/5 and 20/5, and that would give me -15 on top and 4 on bottom. But this is an add-on. You can do this as the very last thing you do if you want, because it's only got to go in your constructor. And if you don't do this, you get fractions that aren't in simplest form, but that's not going to stop you from knowing if your code's doing the right thing. Your 2 doubles should be fine, your 2 strings should be fine, add, sub, mul, div should all work. So you can do this at the very end, if you like. Or if you want to break, if you just want to write some code that looks like C code, which is really what this is going to be. It's not going to have anything to do with objects. You can sort of counterpose and work on your GCD for a while. So that's where I suggest that you may want this private method called reduce. And one way to set this up is make reduce a method that will actually change the numerator and denominator, in this case in X. But there's other ways you can do it, so I said you may also want to make a private method. It's up to you. All right, and I'll update this and say not to use the built-in GCD function. So go ahead and write it. Sound good? All right, I will let you out 30 seconds early because it's Friday. Boom. Yay. All right, have a good weekend. I will see you.